Welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. In the last lecture, we have finished the computation of J1 matrix and we have actually basically shown the case 3 for I not equal to J and P is equal to L with the expression of P to B. And then we have found out in general that this is the expression. So then therefore, just now looking at all the expressions, we can find out that this expression is actually common to all the cases except the case when I is equal to J and P is equal to L, right. So when actually I is equal to J and P is equal to L, so we have got a long expression involving the summation terms, but for other three cases this expression is common, right. So then therefore we can use this expression for all the other cases. Out of these 4 cases we have discussed. So out of these 4 cases, for 3 cases we can use this particular expression, and only for one case, that is I is equal to J and P is equal to L, we have that long expression what we have already derived. So that completes the discussion of J1 matrix. Now let us look at the J2 matrix. So J2 matrix, J2 submatrix. So J2 submatrix is J2 is equal to del P by del V. P vector we have already denoted, but in this case the wave vector would be that V1A, V1B, V1C dot 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 V3A, V3B, V3C. So this is transpose. So here it is essentially, I mean this is for this case, so it is 9 cross 1 in general. V vector is V1A, V1B dot 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 VNB, VNC transpose. So it is 3n cross 1. And because this P vector is also a 3n cross 1, so then therefore J2 is actually a 3n cross 3n matrix. So it is a square matrix. But then square matrix doesn't mean that it would be the case that when I is equal to J and A is equal to B, or rather but then, so I have got some diagonal terms and I have got off diagonal terms. Right. Now let us look that what would be this diagonal and off diagonal terms for this 3 bus system. So for 3 bus system, or rather for 2 bus system, actually for 2 bus system V is, I am sorry, it is 2, sorry, for this 2 bus system, V2A, V2B, V2C transpose. So this is wrong. So this is a 6 cross 1. This is 6 cross 1. So for 2 bus system, this is a 6 cross 1. N is equal to 2, M is equal to 1. We have said that we have got only one earlier it is actually n is equal to 2 and m is equal to 1. So, for 2 bus system we have already taken n is equal to 2, m is equal to 1, right. So, let us look at that what would be the for 2 bus system, what would be J2. It would be del P1A by del V1A del P1A by del V1B, then del P1A by del V1C, then dot 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 del P1A by del V2C. Then it would be del P1B by del V1A del P1B by del V1B, and then dot 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 del P1B by del V2C, right. So, similarly we will continue to do this, and then what we will find is that del Pn. So, in this case, so del Pn is 2, so it would be 2 del P2C by del V1A del P2C by del V1B, and then dot 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 del P2C by del V2C. So, here also you see, so I have got the diagonal terms where I is equal to j and p is equal to L, and all the non-diagonal terms has got all other different combination. So, here it means that my diagonal terms are diagonals are del PIP by del VJL, where I is equal to j and p is equal to L, right. So, I goes from 1 to n, and I as well as j also goes from 1 to n, and PL they goes from A, B, C. So, that is okay. P. Off diagonal terms, for off diagonal terms, there can be 3 terms. There are 3 cases. So, off diagonal terms are is actually del PIP by del VJL, but 3 cases. What are these 3 cases? 3 cases are 1, I is equal to j and p is not equal to L. Case is I is not equal to j and p is equal to L, and case 3 is I not equal to j and p not equal to L, right. So, only these 3 cases are possible for the off diagonal terms. So, we have to derive the equations for these elements. So, then therefore, These three cases cover all the off diagonal terms, and these covered all the diagonal terms. So, we have to find out the expressions for all these four cases. So, first let us look at the off diagonal terms. So, off diagonal terms. So, case 1. Case 1 is, case 1 we said that it is, what is the case 1? Case 1 is I is equal to j, but p is not equal to l. So, I is equal to j and p is not equal to l. Now, we have already got the expression of p to b. So, let us look at that what would be the typical case of p to b. So, one expression would be that del p to b by I is equal to j. So, let us say del theta to a. Now, what would be that? So, del p to b by del theta to a. So, now let us look at this example. So, theta to a is only available at one term. So, only this term. In all the other terms it is not available. So, then therefore, I have to take the partial derivative of this. So, not theta 2. So, it would be not theta 2 del v 2. This is del v 2a, sorry, del v 2a. So, del p 2b by del v 2a. Now, let us look at the case. How many terms has got v 2a? Only one term. First term does not have, second term does not have, third term does not have, fourth term has, but all the other terms they do not have v 2a. So, if I take the partial derivative for all the other terms would be 0, only for this it would be there, and it would be v 2b into y 2b and cosine of this. So, it would be v 2b. So, v 2b v 2b then y 2 to ba cosine theta 2b minus theta 2a minus alpha 2 to ba, correct. v2b y2 to ba, v2b y2 to ba cosine theta 2b minus theta 2a minus alpha 2 to ba. So, in general del p I p by say del v I L, right. Idea is that p is not equal to L. So, that would be v I p y I p L cosine theta I p minus theta I L minus alpha 2 I p L. So, that is the case VIP YIIPL, because we have taken I is equal to j. So, it will be II. So, YIIPL cosine theta IP minus theta IL minus alpha IIPL. So this is L. So this is L. Okay, let us look at case 2. Case 2 is, we have said I is not equal to J, but P is equal to L. So I is not equal to J and P is equal to L. So del P to B, let's say del V, I is not equal to J, so V1 B, P is equal to L, but I is not equal to J, so del P to B by del V1 B. Now let us look at how many terms has got del V1 B. So I have got only one terms has got V1B. In all these expressions, only one term has got V1B. So I have got V2B, Y21BB. So it is, sorry, V2B, V2B, Y21BB cosine theta 2B minus theta 1B minus alpha 21 BB, right? Alpha 21 BB. Now this expression, this general expression can also be written as, for example, del PIP by del say VJL conditions I is equal to J and P not equal to L. So this is for case 1. So for case 1, so case 1, we are still doing case 1 here. So that would be is equal to I is equal to J and P is equal to not L. So VIP, then Y I J P L cosine theta IP minus theta JL minus alpha IJ PL, right? So this is the general term. If I write down in this form using IP and JL, so this is the general term. So in general, if I say that my del PIP by del VJL, the condition is that I is not equal to J and P is equal to L. So that would be IP. So when it is 2B, it is V2B. So it is VIP and then Y21 PP. So it is by IJ PL, because in this case, so YIJ then PL both are B. So when it is B, both are B, so it is PL. My writing is PL. Then cosine theta IP minus JL minus alpha IJ PL. Right, theta IP minus theta JL minus alpha IJ PL. So this is the general term. So let us, so this is case 2, right? So this is in general. Case 3, Case 3 is, we said case 3 is I is not equal to j and p is not equal to l. So, I is not equal to j and p is also not equal to l. So, del p to b by, let us say, del v1 say c. I is not equal to j and p is equal to not equal to l. So, again in this expression let us see, we are doing by del v1 c. So, how many terms are there in containing v1 c? Only one term. You see, this is v1a, v1b, v1c, all the other terms, no other terms has got v1c, only this term has got. So, v2b, y21bc. So, it is v2b, v2b, y21bc cosine theta 2b minus theta 1c alpha 21bc. So, cosine theta 2b minus theta 1c minus alpha 21bc. So, again in general, del PIP by del VJL, condition I is not equal to j, p is not equal to l, that would be again VIP y I j p l cosine theta I p minus theta j l minus alpha I j p l. So, you see, it's very interesting thing is that these expressions are all same. So, these expressions are all same. Right. So, we can simply say now for all the three cases corresponding to the off diagonal terms, the general expressions are all same. So, we can simply say that all off diagonal terms can be calculated just by this expression. It is a very simple expression, correct. Now, let us look at the diagonal term. So, again, as we have seen for the case of J1 matrix, we have seen that for all the, for basically three cases the expressions are same. So, here also for this J2 matrix, for all the three cases, for all the off diagonal elements, for all the three cases the expressions are same. Now, let us look at the diagonal term. So, diagonal term. So, what is diagonal term? Diagonal term is essentially, we said that I is equal to j and p is equal to l. So, that is the case. That means it will be del p to b by del v to b. Essentially, I is equal to j and p is equal to l. So, now let us look at the expressions of p to b, where I do have v to b, everywhere I do have v to b. All the terms in this long expression has got V2B. So I have to take the partial derivative of all the elements. So for all the elements, so let us write it V1A Y21BA. So it would be V1A Y21BA then cosine theta 2b minus theta 1a minus alpha 21ba, right, for the first term, and theta 1 is 0, so it will be theta 2b minus alpha 21ba. So it is 0, so we can simply say that it is not there, theta 1 is 0, so I can say that it is basically alpha 21ba. Then V1b Y21BB, second term V1b Y21BB. Now then cosine theta 2b minus theta 1b minus alpha 21BB plus V1c Y21BC cosine theta 2b minus theta 1c minus alpha 21BC. So this is the third term. Fourth term would be V2A Y22BA cosine theta 2b minus theta 2a minus alpha 22BA. That is the fourth term. Let us look at the fourth term V2A Y22BA theta 2b minus theta 2 alpha 22BA. Now fifth term theta 2 cancels out, so it will be 2V2B into G2BB. So it will be 2V2B V2B G22BB, right. So this is the partial derivative of the fifth term. So this is the partial derivative of this fifth term. For sixth term V2C Y22BC, so V2C Y22BC, then cosine theta 2b minus theta 2c minus alpha 22BC. So V2C Y22BC theta 2b minus theta 2 minus alpha 22BC. Then it would be actually so put it in a common platform, V internal 1, so it would be V3A because it is V internal 1, right. V internal 1 is V3A, Y23BA, Y23BA, Y23BA cosine theta 2b minus theta 3a minus alpha 23BA, correct. You see, then V2B, then again V3B Y23BB, then V3B Y23BB cosine theta 2b minus theta 3b minus alpha 23BB, right. So here what we are doing, so here it would be actually V internal 1 y23 BA cosine theta 2B minus theta internal 1 minus alpha 23 BA. We are replacing this V internal 1 as V3A, and we are replacing theta internal 1 as theta 3A, correct? Now for this also we have replaced V internal 1 is equal to V3A, which is equal to V3B, because we have said that the internal bus, that is third bus, is balanced, and theta internal, and if I take minus commons, it will be theta internal 1 minus 2 pi by 3, theta internal 1 is theta 3A, so theta 3A minus 2 pi by 3, so theta 3A minus 2 pi by 3 is theta 3B, because theta 3B is equal to theta 3A minus 2 pi by B, right? And then V2, and then we can write that V3C y23BC cosine theta 2B minus theta 3C alpha 3 BC, right? Where we have used that essentially, basically where we have used that, where we have used this fact that this V3A is equal to V3B is equal to V3C is equal to V internal 1, and V internal 1, and theta 3A is equal to theta internal 1, theta 3B is equal to theta 3A minus 2 pi by 3, that means theta internal 1 minus 2 pi by 3, and theta 3C is equal to theta 3A plus 2 pi by 3 is equal to theta internal 1 plus 2 pi by 3. So this expressions we have used in the partial derivative term, right? We have used it so that we can write down a general expression. So in general, del PIP by del VIP, it would be 2 VIP GII PP. You see from here I is 2 and P is B, so GII PP plus summation L is equal to A B C, J is equal to 1 to N plus M, right? And then it would be V J L Y I J P L, V J L Y I J P L cosine theta I P minus theta J L minus alpha I J P L, right? Here the condition is where, here the condition is either I is equal to J and P not equal to L, or I not equal to J and P is equal to L, or I not equal to J and E not equal to L. So this summation, everything will go, but only with these conditions. So with these three conditions, this summation will hold good, right. So this closed form expression with these conditions give us the expression for the diagonal terms. So we have already looked into the off diagonal terms. Now we have finished looking into the diagonal terms. So then by this we have now finished the derivation of this J2 matrix. We will continue with the derivation of the other matrices in the future lectures. Thank you.